Hello everyone. Today let's solve the problem number 130, surrounded regions. So what the question states here? Just give me a second here. Why is 0 here? Yeah, this is fine. So what the question states here? We are given an m into n board. You can clearly see here. We are given an m into n board consisting of the letters X and O. So you can clearly see the board consisting of the letters X and O, right? So what is our main task then? Our main task is to capture all the surrounded regions. We have to capture all the surrounded regions, meaning a region is formed by connecting adjacent 0 cells. So we have to connect the adjacent 0 cells. Here you can clearly see we have adjacent zeros here, and this one also we can consider here. So yeah, this whole will be connecting adjacent zeros here. So a region is formed by connecting adjacent 0 cells horizontally or vertically. Horizontally or vertically means left, this one. Horizontally means left, right. Vertically means up and down. We know this one. A region is surrounded if none of its 0 or O cells touch the border. So this is at the border here, right? So they have given a region is surrounded if none of its border, this one, none of its O cells touch the border. This is the border, right? This is touching the border. So a region is only formed when it is if none of its 0 or O's cells touch the border. If a region is surrounded, convert all its O's to X. Here we found the region. So here we are converting this, we have to convert this one to X. This is at the border, so we leave this one as it is. So here you can clearly see X. This is converted to X, and this we leave as it is because this is at the border, right? This forms one region. So the output has to be this one, right? That's what they have mentioned here. You can clearly see XX, 4 X's everywhere except the last row. Last row they have considered XO, XX because this one is at the border O, right? Everything has X in the, each cell has X in it except this one. I think it comes under 3,1. 3,1 here, this one. This is O. This remains as O itself. That should be the output. So in case of second example, let's see what they have given here. We have only one cell consisting of the X. So the output will be same thing. There will be no change, right? So I hope the question is completely clear. So initially what we will do, let's discuss the approach. I'll just consider the same example, example 1. So it will be easier to understand. So let's discuss the approach followed by the edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. So as usual, let's discuss the approach. So let's discuss the approach step by step here. The first thing we have to keep in mind here is we are going with the BFS, breadth first search, right? So just keep this in mind. So I have considered the same example, first example that they have given in the question, right? Step 1, what we are doing here, we are identifying the border O's. Here in this case, this is at the border, means end, right? This is at the border O. So we are identifying this one, nothing but in the 3,1. So here in the 3,1, we have the O at the border, right? So we do not convert these zeros or O's as they are not surrounded by X. See here, one thing is, if we have X surrounded, then only we have to convert them to 0. Here right side is surrounded by X, left side is also surrounded by X, up is also surrounded by X, but down here we don't have anything here in this case. So we do not have anything here down. So we do not convert these zeros or O's as they are not surrounded by X. Here this fails, right? Down it is not surrounded by X. So what we need to do here, we do not convert this zeros to X. This is the first step. So let's move on with the second step. So here what we will do, we will mark non-surrounded zeros. Nothing but we'll be making use of the BFS. As I have said, we'll be making use of the breadth first search or the BFS to mark all zeros that is connected to the border as S. right? Here in this case, this one we will mark this one as yes, that is connected to the border. We will be converting that one to the S in the second step. Now what will happen? This remains same. So x we have for x, then followed by x double x 0. It's x double 0 x, right? I'll just give here x double 0 x. In the third row we have double x 0 x. Double x 0 x, same thing. In the fourth row, what we have to do here, this one we are converting this one to the S. So we'll be making use of the DFS for that. Only the border cells which fails the condition here, this one we have already discussed here, because this is not surrounded by X down, it is not surrounded by X, right? This one which is at the border, the O or the 0 which is at the border, we'll be converting this one to S, right? So I'll just give here X S double X. This will be second step, right? So I hope this is clear. We are making use of the BFS to mark all zeros connected to the border as yes. Let's move on to the step 3. So we are converting remaining O's to the X. So here what we have now in the second step, so you can clearly see here, remaining step, in the second step we have zeros. This one has connected, right? So we'll be making use of the BFS here. This one, when we come here, this one to 1 comma 1, so here we have 0. Next we will move right, we have 0. This one also we will consider here. So right, we have x, so we will ignore this one. So we'll come down here. So this one we will consider 1 comma 1, 1 comma 2, and this one 2 comma 2. This one we will consider. So these are all will be converted to x. So this one we have to keep in mind. In the step 3, we are converting this 0 or O's to x here in the third step. So this will be here x. So this will be 1 comma 1, 1 comma 2. This will be converted to x. Again 2 comma 2 is also converted to x, except in the 3 comma 1. So sorry, this one remains yes itself, right? This one remains yes itself. Now we have this one. Now we have I reached the step 3. So I hope the step 3 is clear. So let's move on with the step 4. Nothing but we will convert s back to 0, right? So we have s here in the step 3. If I come here, we have the s 0. We convert it to yes because it was at the border. It failed the condition that x, it was not surrounded by x down, right? So downwards, x was not present. So yes, this one we will convert back to 0 in the fourth step. So let me come here. So this each cell is having x now, x. So this one, let me write this one quickly, and this one instead of s, this will be converted back to o or 0 here. This one, right? This one I'm speaking of. I hope this is clear. So this is the final output that we got, and this itself we have to display as output, right? So I hope this is clear. So I have mentioned all the 4 steps are given here. You can just pause the video and just have a look into it. Step 1, step 2, step 3, and step 4. So here from step 2, we'll start the BFS from here, right? So I hope step 1 to step 4 is completely clear. Now let's start writing the let's start discussing the edge cases one by one. I hope the approach is completely clear. So here the first edge case that we are going with here is all x board, right? So here we have all the x. You can clearly see here we have all the x. This is the first edge case. So the output will be here no change. The same output we get here, x, everything will be same here. So we can just give here no change for output. This is for the first edge case, all x board. Let's move on with the second edge case, nothing but all o board here. So here no change. Again here output will be no change. Why the output will be no change here? We'll get the same output, same as the output will be same as input here, because all are on the border here. Everything will all are on the border. So no change in the output. It will be same as input. right? No change or same as input we can consider here, or I'll just give here same as input. This is fine. Let's move on with the final edge case. Nothing but single row or column. You can clearly see here single row or column. We are just going with a single row here in this case. So again, there will be no change here as we have the single row. Everything is at the border, so no change. So output remains same or same as input. So this is fine. I hope all the edge cases are clear along with the approach. The first edge case that we considered was for all export, and the second one was for all O board, and the third one was for the single row or column. I hope this is completely clear. Next, let's start writing the code, and I'll explain the code while writing the code itself, right? So then finally, let's discuss the complexities of the code that we have written. Now, let's start writing the code. So let's write the code. The first thing is, let's consider rows and columns. So I'll just give here rows. This is nothing but length of the board, and columns I'll consider here board of 0 dot length. I hope this is clear. The second step is we have to consider all the directional moves for BFS. Nothing but up, down, left and right, horizontal and vertical, right? So here let directions, I'll just consider here this one, right, down, left and up. So I'll just give here up. This is fine. So I hope this is clear. I have just considered the directions here. So right, down, left and up, right? So the next one is we need Q for the BFS traversal. As we are dealing with the BFS, or as we are making use of the BFS, so we need Q, right? So I'll just give here Q. Let's initialize the Q to empty array. So this is fine. So let's come to the first step. We have to add all the border zeros to the Q. Initially, this was the first step according to the approach that we have discussed. So let's add all the border zeros or O's to the Q. So I'll just quickly consider for loop. I'll just give let r equals 0, r less than rows here, or plus plus. This is clear. Next step is simple if condition. So we have to consider first column and the last column. Border ones, border zeros that is present at zeros or O's that is present at the border. We have to add that one to the queue. So we are considering first column and the last column. So simple if condition here for the first column, board of so let me copy the board. So here I don't have to type this one again and again. Board of this one r 0, if this is equal to comparing, right, O, then what we will do, we will add this one to the queue. For adding, I'll just make use of the push here, right, row comma 0, r comma 0. I hope this is clear. This is nothing but the first column. So we have to at the last column, we have to check for the last column as well, right? So here board of r and this one for the last one, columns minus 1. So this one is equal to O. Then what we will do, again we will push this one row calls minus 1. So this is fine. First and last column we have considered. So this is it for the first step. What we did in first step, we were just adding all the border zeros that were present to the queue, right? So again we have to we did this one for the rows. We have to do the same thing for the columns as well, right? I'll just consider one more this one. As we are dealing with the BFS, we have to go with the queue, we have to go with the this one iteration itself, right? So I'll just change the necessary things here. I'll just make this one C for the column. So C instead of rows, let me consider here columns. So this one, let's increment C here. This is fine. If board of here 0 as we are dealing with columns C. This remains same O. Then what we are doing, instead of pushing here rows and 0, this one will be C and 0 and C. This has to be. So column, right? 0 and C. This is fine. If board of rows and column minus 1 we have considered here, this one here first rows minus 1 and this will be column C we have considered, right? So this is fine. This is equal to O or 0. What we'll do, we'll push the last row, right? This has to be last row. So how can we write this one last row? This has to be, again, same thing, row, yeah, row minus 1, rows minus 1 it has to be. We have considered rows, right? So yeah, this is fine, rows minus 1, C. So I hope this is clear. So what we did, we added all the border zeros to the queue. Rows and columns we have considered. So let's come to the step 2 here. So what was the step 2? We have to process BFS to mark all the non-surrounded zeros to S. Now we have the zeros that was presented at the border. So that one we are converting it to S, right? In the second step, we were converting that 0 or O to S, right? If you remember the approach. So how can I articulate that one in the form of code? While q dot length, so then let row and column, I'll just consider here COL. This one q dot shift. This is fine. Shift is nothing but function here. So if not, then we have to continue. We will skip that one. For skipping, we will make use of the continue keyword, right? So I'll just give here if board of row, then column. If we do not have this one present at all, O or 0, if it is not present at all, then what we will do, we will continue, means we will skip. That is the reason I'm making use of the this one, continue. We are making use of the JavaScript right here. So this is simple. We are just making use of the continue keyword here, just to skip if O or 0 is not present at all. So then we will mark that one initially as safe or S, right? So 0 that were present at the border, we are converting that one to S. We have to mark that one as safe or S, right? So board of row. So just give me a second here. Yeah, board of row. This one column I have considered. Yeah, this one. Let's mark this one as safe or S. So I hope this is clear. So next step is we have to explore all the 4 directions. So left, right, up and down, nothing but horizontally or horizontal and vertical. So I'll just make us a simple for loop here. So again iteration. So here d equals 0, d less than 4. As we are dealing with Q or BFS, we have to go with the iteration itself, right? Rather than DFS and this one recursion. So I'll just give here, let's consider new row here equals row plus directions of D, and again new column, let me consider here, equals column plus, so let me copy this one, we paste here directions of D plus 1. So we are just exploring all the directions. So we are just iterating that one. We are just showing that in the form of iteration. That's it. So let me write the simple if condition here. So if out of bounds, right? For that one, I have to we have to write the simple if condition. New row greater than or equal to 0, and again new row less than rows. This is for out of bound, and new column greater than or equal to 0, and new column this one less than columns, and board here. So just give me a second here. Did I miss anything here? board of this one. We have to consider new row and new column, right? So I'll just copy this one here. Just let me paste it over here. This one has to be new column. Let me copy this one here. Let me paste it over here. This one, if it is equal to 0 or O, what we will do, in that case, what we will do, we have to add that one to the queue if it's an O. O is present, so we are adding that one to the queue, because in the step 3, if you remember, we have to convert all the O's that is present in the grid to X, right? Again, back to X, we have to convert that one to X, right? So for that reason, we are exploring the 4 directions. One is horizontally and vertically. Then if we find O, we are checking out of bounds here. And then if we find O, then what we are doing here, we are adding to the queue if it's an O. So here, queue will make use of push here. This one will be new row and new column. So this is fine. I hope this is clear. So I hope this is clear till here. Like, so I'll just come out of this one while loop entirely. So, or yeah, I'll just come out of the while loop entirely. So the next step, if you remember, I have said this one just now, we have to convert all the remaining O's to X, right? Nothing but surrounding regions. And also we have to convert yes, right? Initially the border ones here, you can clearly see the border zeros were there, right? The zeros that were present at the border, we have converted that one to the S. We have marked that one as yes or safe. And here we will be converting back that one to 0 again. And also we are converting, if zeros or O's, any O's is present in the board, we will be converting that one back to the X. O's to X, O we are converting back to X, and yes, we are converting back to O's, right? So that's what we will be doing here. And this is the last step. So again, iteration here for let r equals row 0, r less than rows r plus plus. This is fine. So for again one more for loop for columns. So let C equals 0, C then called C plus plus. I hope this is clear. So for this one, I'll just make use of the simple ternary operator here. Board is there, row, column, let's consider. If we have S present. So if we have S present, or if we have S present here, this step. So anywhere in the border, if S is present, then I can just give here, if border of RC, this one equals S, then what we will do? We will convert this one to O. So we'll be displaying this one O. If not, what we will do? We will convert this one to the X. So we are converting all the O's to X here, right? So that's what we will be doing here. In simple terms, we are restoring safe cells and we are capturing the surrounded regions right here. So I hope this is completely clear. So this is it. Let me format the code once. So here, let me format the code once and let me hit the run button. So this is little bit lengthy, but very easy to understand, right? So we have error here in the line number 18. If line number 18, let me go here. Board this one has to be equals, right? Not equal to. So this is fine. Let me format this one and let me hit the run button. So you can clearly see the sample test cases are getting passed here. So let me hit the submit button. So you can clearly see all the test cases are getting passed here. So the code works absolutely correct in this case. Let's quickly discuss the time complexity and the space complexity of the code that we have written, for the code that we have written. So the approach that we went with here is BFS, or breadth first search. We know this one, right? So what will be the overall time complexity here? The overall time complexity would be here big O of m into n. So Why it is big of m into n here? Because each cell is processed at most once, right? So this will lead to the big of m into n complexity. And also one more thing we have to keep in mind here is BFS queue, whatever queue we are using here, the BFS queue processes every border cell and its connected components in the linear manner. We know this one, right? Second step, this one, if you remember, we broke down into 4 steps, and then we are writing this one in the form of code. So I hope this is clear. This might be little bit lengthier, but it is very easy to understand, right? So the overall time complexity here is big O of m into n, right? So what will be the space complexity here? The overall space complexity would be big O of m into n as well. Why the time complexity and the space complexity here is big O of m into n? Because why the space complexity here is big O of m into n? At the worst case, if all cells are O or 0, so it requires big O of m into n space, right? So for the queue. So that is the reason the space complexity would be big O of m into n in this case. So overall time complexity and the space complexity both are big O of m into n in this case, right? I hope the solution that we have written is completely clear. For now, this is it. Thanks for watching, guys.